Okay, so I wanted to go over some of the more missed questions. This is one of two videos. The other one has the rest of the videos that I had already made a video about. So this is just going to be, I think, four-ish different questions from the Unit 5 Agriculture Progress Check that I wanted to go over with you. So on question 3, we're looking at the benefits of aquaculture. It's important to note that aquaculture is looking specifically at growing fish in a kind of farming scenario for consumption. This is not just going out and harvesting fish. This is growing it like it's a farm. So we're looking for a benefit, an environmental benefit in particular. That environmental piece of it is important. So when we're looking at choice A, where it says raising large numbers of fish will increase profitability, that is a benefit, but that's not an environmental, that is an economic benefit. So it's important that we are reading the question carefully and making sure that you are choosing a benefit that is not just something that's good, but something that is environmentally beneficial. We see that with answer choice B, raising fish using aquaculture and feeding human populations with that harvest reduces the number of fish caught from the ocean. So it helps us with our overfishing problem if we are producing the fish in aquaculture operations instead of catching wild fish populations. For C, aquaculture supports food supply for humans, and the fish can also be released into the wild to repopulate. Generally speaking, aquaculture organisms are not meant to be released into the wild. A lot of times they are genetically very similar. We don't want to introduce those organisms into our wild populations and have them as breeding stock. Sorry, my dog is drinking water over there and it's very loud. We don't want those organisms to get out and interbreed with the wild populations and influence their genetic diversity. So that idea of releasing those organisms into the wild, the aquaculture fish are not the ones that we do that with. There are programs where fish are bred in human care and then released as part of repopulation species survival plans for some more critically endangered species, but that's not the purpose of aquaculture operations. And then the last one, aquaculture results in large amounts of fish that can feed large numbers of people. This part is true and help to increase human population growth. Generally speaking, increasing human population growth is not one of the goals of environmental solutions, and it's also not an environmental benefit. So feeding people, great, that is excellent, but the goal is not necessarily to continue to grow human populations or to and that's also just not an environmental benefit. We're looking for something that is influencing environmental systems in a positive way, and that is best answered with answer choice B. Our next one that we're going to look at, question 6 is one that I answer in the other video. So it is one that was pretty widely missed, but it's not one that I'm going to go over again. So check the other video for question 6 about different fishing techniques and their environmental concerns. Same thing with question 8. Question 8 is addressed in the other video that I sent you in the email. 11 as well. Actually, no, 11 we're going to go over. 12 is in the other video. Okay, so looking at aquaculture, negative consequences. Before we were looking at a positive environmental consequence of aquaculture. Now we're looking at something negative. So we're looking for something bad, and great, nobody chose A or B. C, excessive amounts of nitrogen and phosphorus can leak from the location. This is bad because this can cause eutrophication. If you are adding nitrogen and phosphorus, essentially you're just fertilizing this area, which can cause algal blooms, which can then die and cause oxygen deficiency, have some areas that are completely devoid of oxygen and cause things like fish kills. It's not a good thing. So that is true. That nitrogen and phosphorus is coming from the waste of the fish. As they are being fed, they are releasing the waste after they've eaten and digested, and that is nitrogen and phosphorus rich. They're fertilizing the area around them, and that is negative. For D, other species bycatch may be accidentally removed during harvest. This is a problem with commercial fishing, not with aquaculture. With aquaculture, you're looking at a contained system that is just the thing that you are trying to grow. It's like saying a cow farmer, like a beef herder, is accidentally catching pigs in his harvest. This is a managed stock. This is a managed population that you are containing in some way, and that is not going to accidentally get bycatch. A lot of other fishing methods of providing fish for people do have this problem. That is a negative consequence of commercial fishing techniques, which is discussed in the other video about, I forget what question number it is, but the fishing techniques question. This one, that's not a problem with aquaculture. That's a problem with commercial fishing. So C is our best answer choice. All right. Other ones that I wanted to go over. This one, 12 is in the other video. Same thing with 14 is in the other video. Let me look at this one. Yeah, same thing with this one, other video. If you have questions about that, please go see the link that I sent you. This one, though, I did want to go over. Which of the following would decrease with the manufacture, application, and use of synthetic fertilizers rather than organic? We talked about this a little bit after the movie today, but I wanted to go through this and explain why the right answer is right and why these ones are not correct answers. So we're looking for something that will decrease, something that will reduce in its frequency. With groundwater pollution, synthetic fertilizers are often more water soluble. They're something that dissolves relatively easily in water and can move. This will move with the water as we have leaching, as we have the movement of water that is percolating through the soils and infiltrating into our groundwater. They're bringing these synthetic fertilizers with the water. So that is going to be an increase, something that is happening more with the use of synthetic fertilizers than rather than organic, because organic fertilizers, generally speaking, are going to slowly release the nutrients to provide those to the plants themselves, and they'll be taken up relatively quickly compared to synthetic fertilizers where you're getting a lot really quickly. My dog has my sock. This is Moose. I'll be right back. Sock recovered. Moose still wants to eat it. Moose doesn't have the eyes that Todd does. He's pretty good. Okay, so anyway, what I was saying, the organic fertilizers are going to generally release the nutrients slower. They don't have as much of a chance of being absorbed into the groundwater because they're being taken up as they're released by the plants. With eutrophication, again, that's going to increase. We do see eutrophication with the use of synthetic fertilizers, but that's an increase rather than a decrease for the same reasons as the previous. It is going to dissolve into water easily. It's going to be taken with the water in runoff over to surface waters like rivers and streams and ponds, causing eutrophication in those bodies of water. For recycling of organic matter, what that's saying is we are using the nutrients that are sequestered in the organic matter of the organic fertilizer. So as organisms die, they're put into compost, they're put into these fertilizers. The fertilizer can be waste from different organisms, and that is what they consumed. And so we're looking at the cycling of nutrients that are a part of this system, and that is going to increase. We're recycling those nutrients instead of adding new things into the system that were not originally part of it. And the last one that I wanted to go over that's not in the other video is not this one, I think it's the next one, 21. Yes. Which of the following describes an unintended consequence that results from large-scale agricultural use of water from an aquifer? So with this large-scale aquifer access for the agricultural processes, what we're looking at is pumping out of the groundwater. Remember, an aquifer is the area of the groundwater that is being accessed, having that water pumped out so that we can utilize it for these purposes. So we're looking for something that is not necessarily the goal, but it happens regardless. Much of the water becomes too salty for human consumption because of saltwater intrusion. This could be true in a coastal scenario. So this could happen if we're looking at aquifers on the coast. That's not incorrect, but generally we're not looking at human consumption. Most aquifers are not coastal. So if we're looking for the best answer, this is not it. It is an answer. If you're looking at a coastal aquifer, that is a problem. If you're over pumping, you are going to potentially cause some saltwater intrusion to replace that water that you pumped out. But the main problem is answer choice B. Rate of water use exceeds the rate of recharge. It takes a long time for groundwater to percolate through the soils and recharge the groundwater. This will lower the water table. The water table is the level of water, or the level of where the water is fully saturating the soil. So if you're looking at your water table, that is, I'm going down into the soil profile and finding the point at which my soil is completely saturated with water. That's my water table. So if I'm drawing water out of my aquifer, that is lowering because I'm taking some out. It's no longer saturated at those higher levels. That's the opposite of C. The water table level rises too high, leading to excessive flooding. We are taking water out. The water table is going down. This is not going to happen from aquifer withdrawal. And then agricultural areas contribute to increased carbon dioxide in the atmosphere, leading to global climate change. This is something that can happen with some agricultural practices, but not from the water usage. This is one of those kind of attractive wrong answers, because we do talk about the contribution of these agricultural methods to greenhouse gas emissions in the atmosphere, but it's not because of the aquifer draw out. It's because of all of the other stuff of using mechanized farm equipment, having a lot of waste that is, having a lot of waste that is not properly cycled, that gets decayed, and then we have the release of methane, having a lot of other practices that are contributing to the CO2 emissions. It's not the water draining. Okay, I clearly need to get my hamper off of my laundry off of the floor, because once again, there's this thing with a sock. But that is all of the questions that I wanted to go over for the remaining ones on the progress track. So I'm going to put this up, send all of this to you. And remember, tomorrow morning, I'm doing extra help. So if you feel like you need further explanation, or if I didn't go over one of the ones that you wanted help with, please come to that. Let me know so I can help you out. Have a good night.